So let's practice getting some critical points. So here's a function, and it is a function. It is a composite function, right? It's some sort of radical times a line, right? But if I'm going to find this function, first thing we do is we distribute. And do we all agree that when we distribute x to the 3/5, we get that function? And this is an easy function to take the derivative of. We use the power rule. I don't worry about the coefficient of 4. I bring down the power. 3/5 times 4 is 12/5. Take away 1, I think that's negative 2/5. Take the derivative of that, I get 8/5. Take away 1, I get 3/5. And I immediately look at this, and your first instinct's got to be, oh my gosh, how do I solve this for 0? Because I want to find c's where f prime of c equals 0. So I want to take this stuff and set it equal to 0. This looks like a disaster, do we agree? But when we have these type of problems, we want to do this step, we want to get to one term. We have two terms currently, so we got to do a little bit of algebra 2. So when I look at this now, what makes this a common denominator? 5x to the 2/5. So I'll do this in a different color for you folks out in video land that aren't colorblind. And all of a sudden, I can rewrite this derivative as f prime of x equals 12 minus 8x over 5x to the 2/5. All right. Pretty easy now to see. The denominator can't be 0. Now, can the original function be 0? Yeah. F of 0 is 0. All right. So something's happening there. We don't know what, but the derivative is undefined at 0. But I can tell you what, I can look at the numerator, right? And what makes 12 minus 8x 0? How about 3/2? How about 3/2, right? So I would tell you a critical number, a critical point, happens at x equals 3/2. Now, this would be the only part of the assignment. To tie this kind of back to what we've been doing, I always like to show a picture. All right? So I took a couple seconds in my notebook when I did this problem, and I figured out a couple things. First of all, hopefully you guys see 1, 2, 3, 4. That the x-intercepts are 0 and 4, right? 0 and 4, right? So I knew the x-intercepts, all right? And I knew at 3/2, all right, it actually goes here. And the shape of this curve, when I started doing it, looks like this. And everybody, I'll tell you what happens here at 0. The derivative here is 0, right? And we knew that. And that happens to be a local, and actually not a local, but a global max, okay? Or a local max for sure, okay? But here's the thing. What kind of tangent am I going to have at 0? I have a vertical tangent at 0. What's the slope of a vertical line? Undefined. Guess what the derivative is at 0? Undefined. Oh. All right, so let's try a couple more critical point ones. All right, you just got to see some. I'll forward a page. Pause the video like. I'm going to pause. So our instructions are to still find critical points. All right. So again, we know two things. It's where the derivative equals 0. So our first thing is, hey, let's find the derivative. On this problem, again, I would argue this is a glory problem, right? Power rule, right? Quickly simplifies. What do I have to do with this? I have to set that junk equal to 0, right? Boy, oh boy, I sure hope this factors. All right? Oh, looky, looky. I know the factors are of -1 are plus and -1, right? and I just guess and check until I see plus 3x minus 1x is positive 2x. So this factor is awesome. All right, so what do I got here? I have two critical points. I have a critical point that happens at x equals a third, and I have a critical point of x equals negative 1. Well, those are where the derivatives are 0. So if you wanted to now, before we do the next problem, tie this back into kind of what we're going to be doing, can I use the function here. If I plug in negative 1, what's f of negative 1 for the original function? Negative 1 plus 1 is 0. Minus 1 is 1. We agree just, all right, and then we do f of a third. Gosh, I hate fractions. 127 plus 1/9 is 4/27 minus 9, it's negative 5/27. Icky. Just for fun, I'm going to show you how quick we can. Now, what do we know about the derivatives at those points? We know they're 0. So here we go. What's our y and x intercept this time?
Oh, no,
0, 0.
0.
F of 0 is 0. You guys agree? Then I said at negative 1, it's positive 1. I said at 1/3, it's negative 5/27. Guys, what parent function is this? It is the parent function x cubed, right? You ready for me to draw the whole graph? It has a local max at negative 1 of positive 1. It has a local min of negative 5/27 at 1/3. The only thing I don't know for sure right now is the other two x-intercepts, right? So we could use IVT to put those into a range. And I just gave you pretty much an exact graph of this function in a matter of seconds. Remember what we had to do last year? Had to do a sine table, right? And we never knew the height of these points, right? We always said, oh, that's going to be in calculus. And here we are. But again, it all comes from finding these critical points. All right, let's do a quotient rule. I'm not going to graph it, though. Let's do the quotient rule here. And everybody, don't overthink this. And I'm not going to write it out. We want to keep practicing this so it's automatic like this. Derivative on top. Derivative of z plus 1. 1. Times the bottom. Boom. Minus the top. Z plus 1. Times the derivative of the bottom. 2z plus 1. Dead spot. Let's get back here. Plus 1. All over what? Z squared plus z plus 1 quantity squared. Now listen, I have to simplify this. Remember I was talking about, the last test? We can't, I'm going to solve this to 0. I'm going to have to multiply these two binomials, and then I got to make sure I distribute the negative sign correctly to all three terms, or 4. Z times 2z is 2z squared. 1z plus 2z is 3z. 1 times 1 is plus 1. That negative will distribute. So I get z squared plus z plus 1 minus 2z squared minus 3z minus 1. Does everybody see how algebra can just rail its ugly head and make these problems just painful? And I go very fast because it's just all algebra. I don't want to get bogged into the algebra. The 1 and negative 1 cancel. Z squared minus 2z squared is negative z squared. Z minus 3c is minus 2z. Still all over the bottom. But does everybody see that z is common? So I'm going to stop right now and factor that z out. In fact, I'm going to factor out a negative z. And that gives me positive z plus 2. All right. Now we got to be real careful here. What can't the denominator be? Can't be 0. What are the two critical points from the numerator? We can see what are the two zeros we think from the numerator. 0 and negative 2. So then to make sure we don't screw up, We plug 0 into the denominator. It's positive 1. When you plug 0 into this, it's 1. That's all I care about. I plug in negative 2. Once I know it's not 0, it's not. Boom. Everybody, I just graphed. I now know that these are either a local max, most likely, or a local min, because I know it's a rational function. So we've graphed enough of these to get a feel for that. All right. Again, finding critical points. It takes practice. It's tying together derivatives and how we're going to use them to graph. Does that make sense, kind of?